Hello and welcome all students. How are you? I hope you are safe and well at your home. Students, in this educational platform, we studied the chapter gaseous state of matter, chemical bonding, periodic table, atomic structure and mole concept previously. Now we shall move towards the another important unit of physical chemistry of class 11th, that is thermodynamics and chemical energetics. In this unit, today, in the first class, I'll tell you about the introduction of thermodynamics. See, in thermodynamics is a kind of chapter in which we will use some different terms which you might never heard of. So what are those terms and what are the meaning of those terms that we will discuss in today's session? Introduction of thermodynamics. See, thermodynamics is very important chapter and it is very important for the competitive examination point of view. In the today's session, I will tell you about the definition of thermodynamics. What do we mean by thermo? I'll tell you the scope of the thermodynamics and also limitations of the thermodynamics. All these points we shall discuss in today's session. Alright, so let us start this class now. See, what is thermodynamics? If I ask you a very simple question, what is the definition of thermodynamics? Students, thermodynamics deals with the study of transformation of the energy from one to another form. Means when energy is transformed from one to another form, it is called as thermodynamics. Say for example, when chemical energy converted into electric energy, or mechanical energy is converted into heat, all these conversions, they are studied under the heading thermodynamics. So in this unit we will deal with the thermodynamics. The term thermodynamics is made up of the combination of two words, thermo and dynamics. Thermo means heat and dynamic is the movement. The term dynamic refers to the movement. So thermodynamics is the branch of science that deals with the different forms of energy. See, students, let me tell you, although you might know or you might not know, but we have different forms of the energy, different variety of the energy, and there is a quantitative relation between them by which we convert the energy from one to another form and we calculate the change of that energy. So the energy change that occurs in the physical and the chemical process during this is basically studied under the heading thermodynamics. So what is the scope of thermodynamics? What would be different kind of questions we will be able to answer when we studied the thermodynamics? You would be able to answer how a chemical reaction proceeds. After studying this unit, you would be able to answer this question. Physical and chemical changes take place during the reaction. Whether a chemical reaction is practically possible or it is not possible, you would be able to answer. And how these laws of the physical chemistries are derived. Laws of the physical chemistry, they basically derived from thermodynamics. So you would be able to answer all these questions once you finish this chapter. So I hope now you are getting how important this chapter is. But as a general rule of science, it also has some limitations, like it is applicable only for macroscopic properties, means large number of particles. Thermodynamics is not valid for the limited number of particles. It is valid for the macroscopic properties, large number of particles, large sample. It only considered initial and final state of the system. You must be thinking in your mind, sir, what is the state of system? That I'll tell you later. What do we mean by the state? So it considered only initial and the final state of system. It does not tell us about the rate and the mechanism of reaction. See, rate is what? It is change in concentration of reactant or product, whatever, upon change in time. So the rate or you can say speed of the reaction, and mechanism. Mechanism means by which process, by which steps any reaction take place. We never study rate and mechanism of reaction under the heading thermodynamics. So thermodynamics has nothing to do with the rate and the mechanism. And where we study that? Rate and mechanism of reaction is studied in chemical kinetics. We study them under the heading chemical kinetics, which we shall discuss later. Before we start thermodynamics, let me tell you, thermodynamics is its own vocabulary. There are different terms which are associated with the various thermodynamic process and steps. The first one is system. What do you mean by system? What is surrounding? What do you mean by universe? And what is the boundary? We shall discuss all these thermodynamics terms one after one. The first one is system. What is system? System is the small part of the universe chosen for thermodynamic studies at a given instant or any given time. Alright. In other words, you can also say it is small part of universe which is under investigation. So the part of universe which is under investigation is system. Now the another one is surrounding. What is the surrounding? Whatever the system is, remaining part of the universe apart from the system is surrounding. Say for example, if someday you are studying a simple, very small, tiny drop of water, then that drop of water is system, and the entire universe apart from that drop is called as surrounding. And what is universe? Of course, when you add system and surrounding, they together constitute universe. So universe is system and surrounding. Now what is boundary? As the name says, boundary is the one which separates system and surrounding. So it is the imaginary or real surface. It might be imaginary or it might be real, or line which separate a system from its surrounding. Here in this picture you see this is surrounding and this is system, and this green color boundary, this green color line is the boundary which separates system and surrounding. See students, boundary could be real, like suppose some air is filled in the balloon. Now in this case, this boundary is real. The boundary of rubber which separates air inside the balloon and air outside the balloon is boundary. But in many processes, boundary is not visible or it is imaginary, right? Now we will study the term heat and work. So first we shall study heat. What is heat? Heat is nothing but a form of energy which flow from one system to another system. So heat is nothing but energy which just keep on flowing from one to another system, and it flows just because of the difference in temperature. So if someday I ask you why there is a heat flow, then your answer should be due to the difference in temperature. And also, this is important, heat refers to the random form of energy. It is random form of energy, right? It is not the organized form. Work is the organized form. Heat is the random form. And what is the sign convention of heat? See, when heat is absorbed, it is positively charged. Positive sign is given. And when heat is released, it has given negative sign. So if someday I say Q is equals to minus 200 joule, then it is understood that this heat is released. On the other hand, if I say, then it is understood that this heat is absorbed energy, right? So these are the different units of energy. We can measure the energy in different units. Heat, you can measure the heat in joule per Newton meter, calorie, erg, and 1 calorie is equals to 4.184 joule. And 1 EV, what is EV? EV is another form of heat, electron volt. So 1 electron volt is 1.6 into 10 to the power minus 19 joule. And this is the order of heat. Out of these units, calorie is the largest one, then joule, after calorie, joule, erg, and the least one is EV, the smallest unit of energy, electron volt. Next one is the work. Students, what is work? Work is also a form of energy which transform from system to surrounding or vice versa, or from the surrounding to the system. So work is a kind of energy which is transferred from either system to surrounding or surrounding to system. This is work, and it is organized form of energy. Heat was the random form of energy, and this is organized form of energy. There are two kind of works. One is the mechanical work, another is the electric work. There is third one also, although it is very, occurrence is very small, is the gravitational work. You will see very small involvement of the gravitational work in chemistry. Yes, as far as the physics is concerned, you will see a lot of work over there with the gravitational energy. And work is also of two types. When work is done on the system, please refer the line on the system, which means compression is there. Work done on system, compression is there, decrease in volume. This work is called as positive work. While if the work is done by the system, means expansion of gas. When gas undergoes expansion, it is work done by the system. System is doing work. It is considered as negative sign. Let me tell you one more thing. In physics, because of the different point of reference, when work is done on the system, it is considered as negative work. And work done by system is considered as positive work. While in chemistry, this work is positive and this work is negative. Please note, work also has energy like units like energy, because it is also a unit of energy. But we also measure work in different units like liter ATM, which is 101.3 joule. We also measure work in terms of calorie, or in terms of joule, or in terms of EV. These are the different units of the work. And what is the order? Liter ATM being the largest, then calorie, joule, erg, and then electron volt. This is the order of units of energies, work. Now we shall discuss another term, the internal energy. As the name says, internal, inside. So every system has some quantity of matter associated with a definite amount of energy, and this energy is called as internal energy. In simple words, system has different kind of energies like kinetic energy, potential energy, and some other energies. So sum of the all possible energies of system is called as internal energy. So internal energy includes intermolecular energy, vibrational energy, rotational energy, translatory energy, electrical energy, nuclear energy, and moreover potential and kinetic energy. So I can say that internal energy, symbol of internal energy is E, capital E or capital U. So internal energy is equals to the sum of potential energy plus kinetic energy. It is sum of the potential energy and kinetic energy, right? Now the characteristics of the internal energy. So internal energy is an extensive property. Students, you must be thinking, what is extensive property? See, if someday I ask you, what is the volume of water? How much is the volume of water? Then definitely you will say, sir, how much water? What is the volume of water? We can only answer this question if you tell us how much is the amount of water. It is not like that volume of water is always constant no matter how much the amount is. This amount varies. So volume is extensive property. It depends upon the amount of substance. Similarly, internal energy is extensive property. It depends upon the amount of substance. And yes, it is state function. It depends upon the initial and final state of the system, and it does not depends upon the path which is followed by system. So there is no change in the internal energy in the cyclic process, because in the cyclic process, initial and final state are same, and as it is a state function, its value will also same, right? So internal energy of ideal gas is the function of temperature only. This is very important, students. So very soon you will see that there are two kind of gases, real gas and the ideal gas. In the ideal gas, internal energy, it depends only upon temperature. For normal cases, internal energy depends upon temperature and intermolecular force of attraction. But for ideal gas, there is no intermolecular force of attraction. So the internal energy of ideal gas is the function of just temperature, and it is measured in terms of joule and erg. Internal energy as the state function. Now we will see the change in internal energy by doing work. Take a system containing some quantity of water, and it is insulated. It is present in the insulated thermos flask. Let us bring the change in internal energy of the system by doing some work. And how you will do some work? Let us call the initial state of the system as A, and the temperature is TA, and internal energy as UA. Are you getting it? We have some quantity of water in the insulated thermal flask in which energy cannot be exchanged, and it is thermos flask. And in the initial state A, temperature is TA and internal energy is UA, which changes in the final state when temperature changes. So it is the function of temperature only. Now we shall discuss enthalpy. Now what is enthalpy? What do you mean by enthalpy, students? Enthalpy is also kind of energy. Like internal energy was the energy, enthalpy is also energy. But enthalpy is more important. It is also called as heat content of the system, or the total heat of system. Called as total heat content of system, or heat content, or total heat, or simply heat. When we refer any of these words, we mean to say enthalpy. And what is enthalpy? See, in any gaseous system, apart from the internal energy, there is one more energy. Apart from the internal energy, there is one more energy, which is called as PV energy, pressure volume energy. So enthalpy is nothing, simply sum of internal energy and pressure volume energy. It is sum of the internal energy and pressure volume energy. PV energy of system, pressure volume energy of system, and internal energy is called as enthalpy. So as it is a sum of these two energy, it is also extensive property. It is also extensive property, and it is state function. Means this also depends upon, it depends upon initial and the final state of system. For solid, liquid and gas, we change the we calculate the change in internal energy and change in enthalpy, and this formulation came: delta H is equals to delta U plus delta NGRT, in which this delta H is it refers to the change in enthalpy. Delta U means change in internal energy, and delta Ng is what? It is total gaseous mole of products minus total gaseous moles of reactant. Total gaseous moles of product minus total gaseous moles of reactant. This is the relation between internal energy and enthalpy. Now we will discuss the properties of system. There are two kinds of properties, extensive property and intensive. What do you mean by extensive property, which is also called as extrinsic property? These are the properties of system whose value, magnitude, depends upon the quantity of matter present. How much matter is present? Like mass. If I ask you what is the mass of water, definitely you will ask me, sir, how much water? So the mass of water is never fixed. It depends upon the amount of water. Same like volume, surface area, internal energy, free energy, enthalpy, entropy, and heat capacities. These are the different thermodynamic terms which depends upon the amount of substance. Another one is the intensive properties or intrinsic. What are these? These are certain properties of system whose magnitude does not depends upon the quantity of matter present. No matters how much the quantity is, their value will remain constant. Say for example, temperature, pressure, density. You see, density of water is always 1 gram per ml. No much how much the amount of water is, whether it is a glass of water or it is a tablespoon of water, density is always same. Viscosity, refractive index, molar heat capacity, concentrations, potential of cell, pH, melting and boiling point, vapor pressure, surface tension. These are some properties, thermodynamical properties, which not depends upon the amount of substance. Intensive. Then what is heat capacity? What do you mean by heat capacity? Amount of heat required to raise the system temperature by just 1 degree Celsius. If you want to raise the temperature of system, see, amount of system is not mentioned here. It is not given that how much is the amount of system, but whatever the amount of system, heat required to raise the temperature by 1 degree is called as heat capacity. The increase in the temperature is directly proportional to the heat transferred. So Q is directly proportional to the change in heat, and this constant we put here is called as heat capacity. Importantly, C depends upon size, composition, and nature of system. It depends upon size, composition, and nature of system. When heat capacity of 1 mole substance is what? It is heat capacity divided by the number of moles. So the heat required to raise the temperature of sample is this much, C into m into dt, and this is small c into m becomes heat capacity, and this small c is the specific heat of the substance, m is the mass of the substance, and delta T is the change in temperature. You know what is the specific heat? It is required heat to raise temperature of 1 gram substance by 1 degree Celsius. So suppose if you want to raise the temperature of 1 gram substance by just 1 degree Celsius, that is called as specific heat. Alright. So this is how we calculate the specific heat and the heat capacity. Now there is a relationship between Cp and Cv. What is Cp and what is Cv? Cp is the heat capacity at constant volume. The word V refers to the volume. If you increase the temperature of gas by 1 degree, keeping volume constant, this is called as heat capacity at constant volume, Cv. The formula of Cv is Cv into delta T. There is another constant Cp. Cp is what? It is heat required to raise the temperature of substance by 1 degree centigrade at constant pressure, keeping the pressure constant, and this value is Cp delta T. And the difference between Cp and Cv can be derived from ideal gas equation as Cp minus Cv is equals to R. Mayor's relationship. In the coming classes, I will tell you about the numericals of the Mayor relationship and how we will use this formula for the laws of thermodynamics. In this segment, we will keep this class up to here only. Remaining we shall see in the next class. Thank you so much for watching this session. Keep coming and keep studying.